Hello friends, in today's question, a block of base 10 by 10 centimeter and height 15 centimeter is kept on an inclined plane. The coefficient of friction between them is square root of 3. The inclination theta of this inclined plane from the horizontal plane is gradually increased from 0. Then, so we have these four options. So we have basically find out the angle at which the sliding or the toppling is going to start. Okay. Or further comparison will be drawn that whether it is going to start to slide first or it is going to topple first. So basically we are going to find out theta and for the sliding as well as for the toppling angle with respect to the horizontal. In the first case, let us do for the sliding condition. For sliding condition, so let this be angle theta, and we have the square block. In the downward direction, we are going to have mg, which can be divided into two components. This will be angle theta, so we are going to have mg cos of theta, and this will be mg sine of theta, and we are going to have a normal n, and if it is sliding downward, so we say there is a frictional force Fr will be acting in the opposite direction. So we can write the equation that for just sliding, mg sine of theta should be equal to our frictional force Fr. Mg sine of theta should be equal to Fr, and Fr is coefficient of friction multiplied by the normal n, and here n is equal to mg cos of theta. So substituting this value, we get mg sine of theta will be equal to mu mg cos of theta, and mg cancel out with mg. So from here we get sine of theta divided by cos of theta is equal to mu, or we can say tangent of theta, and mu is given as square root of 3, so this will be square root of 3. So we can say that value of theta will be equal to tangent inverse of square root of 3, or we can say theta will be equal to 60 degree. So basically means as theta is gradually increased from 0 to just to 60 degree, at that particular moment when the angle reaches the 60 degree, this block starts to slide. Okay, so let us say we write this theta as theta sliding and is equal to 60 degree. So when theta reaches the value of 60 degree, the block just start to slide. And now let us find out for the toppling. So you can say for toppling effect. So let us once again draw the block. So this is our block, and once again we are going to have mg and divided into two components. This will be theta, and this will be mg cos of theta, this will be mg sine of theta, and we are going to have a normal n and a frictional force Fr. Now we assume that this block topples about this point, and let this point be called as A. this angle is theta. So we say toppling effect about point A. About point A. And it will try to topple about this dotted something like this. Okay. So herein there are total, you can say, 4 forces: mg sine theta, mg cos theta, frictional force, and normal. So total 4 forces are acting on the block. Out of these 4 forces, 2 forces are contact forces, normal as well as force of friction. So you can say 2 forces, normal and frictional force, are contact forces. So as the block will start to topple, these contact forces will be acting exactly at point A, because it is going to topple about point A. Okay. So you can say that while the block topples about point A, so we can say only point A will be in contact with the inclined plane. Okay. So therefore, the torque produced by these 2 forces will be 0. Therefore, the torque produced by these 2 forces which are normal and frictional force will be 0. Okay, because they will be acting exactly at the point, you can say, point A. So there will be no you can say distance or perpendicular distance between the force as well as the point of contact where the block is going to topple, because torque is equal to force multiplied by R, where R is the perpendicular distance between the applied the force and the point where it is going to topple. So in this case, the normal as well as frictional force will be exactly at the point A. So value of R will be equal to 0. Therefore, torque produced will be equal to 0 because of the normal as well as because of the frictional force. So therefore, you can draw a conclusion that only 2 forces mg sine of theta and mg cos of theta will be able to produce torque about the center of mass. About center of mass. So let us draw these 2 forces. So this is our block. We have mg cos of theta, and we have this mg sin of theta, and the perpendicular distance, its base is given as 10 by 10. So therefore this distance, this is center of mass, so this distance will be equal to 5, and this is the point of topple, and the height is given as 15 centimeter. So this distance will be equal to 7.5. Yeah, it is 15 centimeter. So we have two forces, mg cos theta, which will be acting at a distance 5 from point A, and we have mg sin theta, which will be acting at a distance 7.5 with respect to point A. And for the torque produced by mg cos theta, so you can say torque due to mg cos theta, so let us write it as torque mg cos theta, and torque due to mg sin theta, and let us write it as torque mg sin theta. So for a stable equilibrium, these two torques should be equal, because one will be clockwise and other will be producing torque counterclockwise. Okay, so you can say for stable equilibrium, torque because of mg cos theta will be equal to torque because of mg sin theta. So we have a force mg cos theta acting at a distance of 5, and we have force mg sin theta acting at a distance of 7.5 with respect to point A. Therefore this mg and mg cancels out, so we can say our sine of theta divided by cos of theta is equal to 5 upon 7.5, or we can say from here that theta will be approximately equal to 33.66. That means as the angle is raised, as the angle of inclination is raised from 0 to the value of 33.66 degree, the block will just start to topple. Okay, so let us write this theta as theta topple. Is equal to 33.66. Now let's make a comparison between the theta slide and theta topple. So comparing the angle of sliding and angle of toppling. So the comparison, we know that theta slide, which is our 60 degree, is greater than theta topple, which is 33.66. So it means theta topple, we are going to reach theta topple first, as the angle of inclination is increased from 0 degree. So you can say as the angle of inclination of the incline is increased from 0 degree theta topple will be reached first. Therefore, we can write that block will start to topple first. Therefore, block will topple first. Okay. So there are these 4 options, and it says that at theta is equal to 30 degree, the block will start to sliding down the plane. So we know the angle of slide is 60 degree, so this is false. The block will remain at rest on the plane up to certain theta, and then it will topple. So this is true basically because this is a general statement and there is no such value of theta is taken. It states that it remains at rest on the plane up to certain theta and then start to topple. So this is correct statement. And at theta is equal to 60, the block will start sliding down the plane and continue to do so on the higher angles. So we know the sliding starts at theta equal to 60. So this is true. So any angle which is greater than 60 or equal to 60, the block will start to slide. And it states that at theta equal to 60, the block starts sliding down the plane, and on increasing further theta, it will topple at certain theta. But we found out that the angle of topple theta is less than 60 degree. So this statement is false. Okay. So we have only 2 statements that are true, that B and C, and A and D are false statements. So we can write that statement B is true because here it is mentioned that up to certain theta, whereas theta value is not mentioned, but we found out the value of theta for topple is 33.66. Okay, so B is true, and C is also true. C states that at theta is equal to 60, it starts sliding down. So we already proved that at theta is equal to 60, it starts sliding down. Okay. So C is also true. So we have these 2 statements which are true, and rest statement number A and D are both as false. So this completes the question. Thank you.